Hey guys, this is Mr. B. So let's learn a little bit more about weathering and erosion. As we've learned, weathering is the breakup of rock due to the exposure to the atmosphere. So weathering is caused by weather. That kind of makes sense, doesn't it? Weathering actually involves two processes that often work together to decompose or break down rocks. So weathering is actually the destruction of rocks. And we'll get to those in just a second. The most important thing that you've got to always remember about weathering, though, weathering produces sediment. Weathering changes rock into sediment. Sediment turns into soil. Without soil, there'd be no plants, no life on our planet. So weathering is crucial. Weathering changes rocks into tiny particles called sediment. Those two processes are called chemical and mechanical weathering. As you can see in the cartoon on the left, this guy's in the chemistry lab and he's doing who knows what. And on the right, well, mechanical weathering, that's just breaking rocks up. Okay, the first of the two types is chemical weathering. Chemical weathering or decomposition takes place when at least some of the rock's minerals are changed into different substances. And as we all have learned already, rocks are made from minerals, so there's always going to be minerals present. So chemical weathering actually changes these minerals into something different, into a different type of mineral. Chemical weathering involves chemical processes which can include rain forming with other chemicals to dissolve rocks, plant roots that can actually slowly dissolve themselves into rocks so they can stick to them better, oxidizing, which we know as rust, and even demineralization by water. Again, this would be the dissolving of rocks by water. So here are three processes that are part of chemical weathering. The first one says dissolution. Well, dissolution is actually just a fancy word for dissolving. So some minerals in certain rocks will actually dissolve pretty easily. Rainwater can have leaves dissolved in them, and these leaves and water will form a real weak acid. As it drips down through this limestone, will dissolve it. Okay. Oxidation, some minerals like this piece of magnetite here, when they've got so much iron in them that all they've got to do is get wet and exposed to the air and they'll start to rust. So oxidation, minerals combine with oxygen and they form a common form of rust. And then there's hydrolysis. Hydrogen ions get mixed up with other elements, and what will happen is something like a piece of feldspar, which is very hard, can get so soft it'll turn into a piece of kaolin, which is as soft as talc. So hydrolysis actually takes a hard mineral and can make it turn into a very soft mineral. I almost forgot to give examples. The dissolution is common when you find caves underground, or the caves themselves may be formed where waters drip down through huge layers of limestone and dissolved away the limestone, leaving behind these caves. And also in caves where you find these structures inside called stalactites and stalagmites, they're deposited after water has dissolved the limestone. Oxidation, well, just leave your bicycle out in the rain a while and you'll see that. And hydrolysis, here in Georgia, down here, our part of Georgia, one of our important minerals that we find is kaolin. Kaolin is a very valuable type of clay that's used for many commercial products, and it's formed as a direct result of feldspar that used to be underneath the ocean when our part of Georgia was underneath the ocean. Mechanical weathering. Now this is the fun stuff. Mechanical weathering involves physically breaking rocks into fragments called sediment without changing the chemical makeup of the minerals within them. Basically, big rocks get broken up into smaller pieces called sediment. Mechanical is physical. You actually have to move or smash or crush or do something to make it smaller. Mechanical makes it smaller. There are four main sources of power that make these pieces smaller. So there's four main power sources for mechanical weathering. One of them is gravity, water, wind, and waves. Of these, water causes the greatest amount of weathering. So on a planet that's 75% covered with water, that makes sense that most of the weathering on our planet is going to be caused by water in some form or another. Point of clarification here. Ding, ding, ding. If a particle is loosened by weathering but stays put, it's just called weathering. If it starts to move, though, it's called erosion. Weathering breaks it down, erosion moves it out. And as you learn more and more about it, you'll realize that mechanical weathering and erosion, they can be a little bit confusing sometimes. Mechanical weathering processes are also erosional. So let's see what we're talking about here. Ice wedging, everybody's favorite. Ice wedging is the freezing and thawing of water in cracks. So let's say a rock gets wet and there's these little tiny little pores in the rock. Well, some water soaks into that rock. Later on it freezes. Well, as we know, water gets bigger when it freezes, so it makes this hole a little bit bigger. So now multiply that by 1,000 years. Pretty soon you got a great big crack in the rock. That crack fills up with water, freezes one more time, and bam, we break off a piece of it. So ice wedging is caused by the continual freezing and thawing of water in rocks. Plants also cause a type of mechanical weathering. The roots of plants are very persistent. It means they never give up. We've all seen grass growing up through the pavement. We've seen tree roots growing down through rocks. We've seen the sidewalks here in town pushed up and moved around by plant roots. So plant roots are very, very strong. Plants have a lot to do with breaking down and weathering rocks, which is ironic because plants need soil to grow in, and weathered rocks turn into soil. It's also important to mention right here that plants can actually cause both chemical and mechanical weathering. Like we said earlier, some plant roots have a little tiny bits of acid so they can etch or grow into the rock to help them hang on. And then of course we have the plant roots that just grow in and burst the rock right open. Check out this tree. Man, it is definitely made mincemeat out of that rock. Look at that. That's pretty cool, isn't it? Abrasion is caused by friction. If you've ever played ball or been running in the gym and slipped and fell down and you skint your knee and you got what we call a raspberry, well, that's an abrasion. As you can see in this picture, this rock sticking up in the desert somewhere is severely abraded. Either wind and water both can cause abrasion. In this case, the wind has been blowing sand up against this rock for so many thousands of years, it's really carved it down. And if you ever go to a fast-moving river, especially up in the mountains, you'll see all the rocks might be really, really smooth or rounded. That's because the water has flowed over those rocks for so many, many millions of years, so many years, that it's actually sanded or smoothed that rock down. That's abrasion. Gravity is also one of the forces that can cause weathering. Gravity has a powerful effect on all three, though, really, weathering, erosion, and deposition, because when gravity gets to work, it doesn't just break something, it actually usually winds up moving it and then putting it down somewhere else. As we know, gravity never stops, so anything that is high above the ground can be pulled down. In this picture, the side of the hill finally broke loose and fell. Gravity, along with other causes of weathering, made these rocks break loose. So it could have been a little ice wedging, who knows, but the rock got loose enough that gravity finally just kind of pulled it down, and then once it started falling, gravity moved it somewhere else, so that was the erosion part, and then once it hit the ground, there was nowhere else for gravity to move it, so that was the deposition. Here's our picture of abrasion again. This just tells us that this picture was actually in Antarctica. Man, looks lonely, doesn't it? In addition to ice wedging, which we talked about earlier, ice really has another major role it can play in weathering, and that's caused by glaciers. As we've learned in the past years of our schooling, glaciers are like giant rivers of ice, and they're moved by gravity, so they're slowly going downhill. Glaciers and avalanches, which are You know, when you got a huge snowfall and it suddenly gets broke loose and it goes tumbling down the hill. Avalanches move super, super fast. Glaciers can move as slow as a couple of inches a year. But anyway, glaciers and avalanches, they cause weathering as the ice moves both rocks and other types of sediment downhill. In this diagram, you'll see where two glaciers are coming down different mountains and they meet together. The kind of cool thing about this picture is you see the black areas that are referred to as moraine, medial moraine, and glacial moraine, lateral moraine. Don't worry about those fancy parts, but the moraine itself, those are rocks and soil that have been picked up by the ice and pushed along. There's even some embedded in the rock in the ice itself. So glaciers move by gravity. These huge sheets of ice move slowly to lower areas. As they slide across the ground, rocks get caught in the ice. The glacier then drags these rocks across the ground. These rocks can carve grooves called striations into the bedrock. As the glacier melts, these rocks, soil, and other debris that's been carried by the glacier, they get left behind. This left behind material is called a moraine. Here's just a couple of pictures. On the left, you'll see some striations. If you look real closely, you see look like lines have been cut into the rock. A glacier did that. And on the right, you can see several rocks. The picture says 3, but I actually see 4 pictures. And you can just visualize how they were being carried by a glacier. And as the glacier melted, it left behind these rocks. Now that we've been talking about weathering and what causes it, we can think of how other things like flash floods, you know, lots of water all of a sudden, a mudslide, like in California, a hillside gets so wet that it just breaks loose, landslides, and other things, mudslides and landslides, these are called mass wasting. Wasting is when a huge body of soil or breaks loose and just suddenly moves to another location. Mass wasting is erosion caused by gravity. This hillside was pulled downhill by gravity. Some other forces may have weakened the bottom of the hill before it fell. And if you look, you can see this. I don't know if I'd stand if I was those people, because you can see where that obviously fell. Got to be California. Got to be California. So keep this in mind. Weathering is the breaking down or the destruction, either chemically or mechanically, into smaller pieces. Erosion involves the removal and transport. Erosion, I like to think of erosion as escaping. It's going to go somewhere else. Erosion is escaping. Wind, rain, streams, these are things that cause erosion. Can you think of some others? Perhaps gravity? Anything else you can think of? Okay, so from here, what I want you to do is get out a piece of paper and talk to your group, and I want you to take your time. You can stop and start the video from here and answer these questions, but don't just write something down and guess. I want you to discuss them. I want you to use your brains. Do a little research if you need to, but come up with some good answers. Okay, do your best. Okay, so if you have any questions, come talk to me about this, okay?